Welcome to Homework Lib.
Reaction of hydrogen gas plus iodine gas that is going to be in equilibrium with 2 of Hi as a gas. We know that the reaction mixture that is going to be at equilibrium at 175 Kelvin is going to have the following pressures. The pressure of H2 is going to be 0.958 atmospheres. The pressure of I2 is going to be equal to 0.877 atmospheres, and the pressure of Hi is going to be equal to 0.020 atmospheres. So everything here is given up to 3 significant digits. So with this information, what we can get is the value for Kp, which is going to be equal to the pressure of Hi squared divided by pressure of H2 times the pressure of I2 at equilibrium. The result for Kp in this scenario is going to be equal to 4.76 times 10 to the minus 4. So this value for Kp is going to be important to us because we're going to employ it next. Now we're given that a second reaction mixture, also at the same temperature, is going to have the following pressures. The pressure of H2 is going to be equal to the pressure of I2, equal to 0.628. And the pressure of Hi is going to be equal to 0.101 atmospheres. So with this information, we can calculate the coefficient of concentration in terms of pressure, which is going to be very similar to the one for Kp, but in this case, we're considering that the reaction is not at equilibrium. So in this case, the result is going to be 2.59 times 10 to the minus 2. As you can see, clearly, the value for Q is larger than the value for Kp. Thus, that means that the reaction will go to reagents. With this information, we want to know what is going to be the pressure of Hi at equilibrium, at the new equilibrium that we are going to find. So in order to do this, we're going to consider first that the reaction will go towards the reagents. So we're going to have the inverse of this reaction. We're going to have 2 of Hi that is going to produce H2 plus I2. We're going to write down our ice table. And the initial concentration that we're going to get, instead of concentrations, we're going to use atmospheres, right? So all of the values over here are going to be in atmospheres. So 0.101, 0.628, and 0.628. The amount of change in this case, we're going to label it as minus 2x, plus x, and plus x. And at the equilibrium, we're going to get 0.101 minus 2x, x, and x. Now consider that the equilibrium constant for this new reaction, nu, is going to be equal to 1 over the equilibrium constant for the old reaction, because we're considering the inverse process. Okay, so plugging in the value of 4.76 x to the minus 4, the result that we're going to get is 2100.84. This is going to be the Kp for by new equilibrium. And this new value, oh, sorry, over here, it should read 0.628 plus x and 0.628 plus x. Sorry about that. So now this new value for Kp, which is this number, is going to be equal to 0.628 plus x times 0.628 plus x divided by 0.628 101 minus 2x. This comes from the equilibrium pressure of H2 times the equilibrium pressure of I2 divided, over here, squared, divided by the equilibrium pressure of HI squared. So, as you can see, we're going to have a quadratic expression on x. We know that the value for x is not going to be small compared to the initial concentration, so we're going to need to solve the full relation. So over here, just to make the expression a little bit simpler, this is going to be 2100.84, and this will be equal to 0.628 plus x squared divided by 0.101 minus 2x squared. So over here, what we can do is a trick in which we're going to take the square root on both sides of the equation. So this is going to be square root of 2100.84, and this is going to be equal to the square root on the other side, which is simply 0.628 plus x divided by 0.101 minus 2x. So now we just need to solve for x. This is going to become a square root of 2100.84 multiplied by 0.101 minus 2 times this same square root, 2100.84, times x, and this is going to be equal to 0.628 plus x. Putting the x on the same side and the numbers on the other, this is going to be times 0.101 minus 0.628. This is going to be equal to x times 1 plus 2 square root of 2100.84. Here I just factorized the x from the right hand side. So with this, the value for x will be square root of 2100.84 times 0.101 minus 0.628, and all of this divided by 1 plus 2 times the square root of 2100.84. And with this, the value of x is going to be equal to 0.04318 atmospheres. Because remember that the value of x is going to be of pressure. So with that, the equilibrium pressure of HI was equal to 0.101 minus 2 times x, giving us, which up to 3 significant digits is going to give us 0.0146 atmospheres. So this is the pressure that was asked for us in this scenario. But we can also have the pressures of H2 and the pressure of I2 at equilibrium, since both of them are going to be equal to 0.628, in this case, plus x, as we can see from here. Which is, again, up to 3 significant digits, 0.671 atmospheres. So these are going to be the equilibrium pressures for all of the molecules that we're going to have in this reaction mixture. But the one that was asked specifically was the one of HI. So with that, it would be all. Thank you very much and have a good one.